Hello everyone, this is Camper here. Today I want to show you another demonstration video how to build your own narrow FM scope receiver with the real-time recorder. Today I want to show you how to build the total of 38 blocks. So it's a big tutorial today. This is a very good software we need to build today. Advanced narrow FM scope receiver with real-time recorder. So the recording file, when you use your analog radio, when you push the button in specific frequency, you have a 3-scope view. In this software you see the wide scope and the narrow scope and the average spectrum scope and the decimated channel. I will show you how to do these 3 scopes together, so you can hang the center of that frequency in narrow FM. You can hang it and you can correct the shift frequency to make it exactly at the center of that frequency and recording it. And when you just push the button in your radio and recording that frequency, and when you release, it's recording that activity, and when you push the button again, the wave file continuously add these specific, like for 4 seconds activity, you can add it step by step, all at the same wave file. So you can easily use the like a VLC software to replay all these activity. Okay, now just create a new. We are using a Qtgi, so let's create a new Qtgi block. So let's define the ID like what you like. For me, MWK Advance narrow FM recorder. And the title MWK Advance narrow FM scope recorder. Let's make it my name, scope. Okay. Okay, now we need to bring a Qtgi range. So let's bring it. Let's make it clear here. Let's delete this variable by default. Okay, let's define it as a dmod. BB freak, and let's label it as a dmod BB freak. Let's make it this hertz range, and now let's close it. And the default value, let's make it minus 15 E3, and the start let's make it as a minus samp, but we will define it now. Samp rate, we need to define these. Okay, just follow me step by step. Minus samp rate with 2 like this, and let's make it stop value at samp rate with 2, and the step let's make it 5e3. Okay, count on the slider, and the minimum length 200. Let's make a GUI hint at the 3, 1, 1, 3. Make it at the corner. As you can see here, the red line here is appearing in start and stop because we not define yet this block samp rate. Okay, no problem. The red, we will define it. Just follow me step by step. Now let's bring a low pass filter tabs. Low pass filter. Okay, I'm sorry, it's the low pass filter tabs. Low pass filter tabs. Let's put it here. Let's make it again, it's 1, it's okay, and the sample rate in hertz, let's make it 1, and the cutoff frequency, let's make it 0.090, and the transition width, let's make it 0.010. Okay, now we need let's check all this, it's good. Okay, now we need another low pass filter tabs. Let's put here, and the sample rate, let's make it sample rate like this with a 25. The cutoff frequency, let's make it as a 12.5 E3. Okay, the transition width, let's make it as a 1 kilohertz, 1 E3, and the cutoff frequency is 12.5 kilohertz. Okay, the sample rate here is good. Okay, now you see this rate because we not defined this. We not define the value of sample rate block. Okay, no problem. We will define it. Let's make another low pass filter tabs. Let's put it here, and now let's put the gains 1, 0, and the sample rate, let's make it as a final rate ID. We will define the final rate too. Just follow me step by step. The cutoff frequency, let's make it 3500, and the transition width, let's make it 500. Okay. Okay, now we need to bring a Qtgi range. Qtgi range. Let's put it here. Let's define it ID as a center frequency, center freq Let's label it as a center frequency. Let's make it in megahertz. Now close. And the default value for testing, let's make it as a 446 E6. 446 megahertz, the default value. And the start from 440, the range of starting E6 440 megahertz to 470 E6. The steps, let's make it as a 12.5 E3. The steps is 12.5 kilohertz. And the widget, let's make it counter. And the minimum length, let's make it 10. And the GUI hint, let's put it in 1,4,1,4 position. Okay. Now let's bring another Qtgi range. Let's put it here, and let's define it as a squelch dB. Squelch dB. Let's label it as a squelch and let's make let's type dB here, close it. Okay, it's look nice. And the default value, let's make it minus 50. It's good. And the start in minus 100 and the stop in 0. The step, let's make it 5 and make the widget counter and slider, and the minimum length is 200. It's good. GUI hint, let's put it in 5,113. Sorry. Okay. Okay, now we need another Qtgi range. Let's put it here. Let's define it ID as a gain dB. And then let's label it like HW hardware gain. And let's make it in dB. Close. Forget to put here in the first, like this. Okay. Make sure it's the type is float, and the default value, let's make it 30 is good, and the start in 0 and stop in 70. And the steps is 1. And make sure counter and slider, and 200. Let's put the position GUI in 4,1, 3. Okay. Now we need let's bring the variables here. So let's type variables. Let's bring variable number 1. Let's put it here. Let's define it as a file name. For the file recording, file name, let's put a value what you like. I just want to put test.wave, wave. Okay, now we need another variable. Let's put it here. Let's define it ID as a sample ratio. So let's make a sample ratio, sample ratio. Okay, now let's make the value as a sample rate, like this, 1E6 sample rate with 1E6, like this. Okay. Okay, now we just need to define another variable. Let's put it here. Let's move this here. Let's define it as a final rate. We need the final rate variable, so let's define it as a final rate. And now in value, let's put it sample rate with initial decimation with 2, with initial sample rate with 1E6. So let's put this value here, like here, like what you see. Okay, in this variable final rate, as you can see here. Okay, now let's define another. We need another variable. Let's put it here. Let's define it as a initial decimation. So let's define it as a initial decimation. Let's put the value 5 is good. Okay, now another variable. As you can see here, the blocks, we have red lines because we not define all variables. After we define all variables, the block lines, the red lines here disappearing. So right now it's telling us there is error, no variable defined yet. So here let's define a sample rate. So as you can see, after that you will see some red lines disappearing. So let's name it as a sample rate and make the value 1E6, enough, 1 megahertz. Okay, as you can see here, all blocks now it's defined as every input here is correct. Okay, let's manage all these blocks close together. Now we need another variable here. Let's put it here. Let's define it as a Fft length. Fft length. Okay, the value we need to make a 265 with input power, with np.log, with np.ceil, with sample ratio, with np.log. Just put here this is a value here. Okay, like this. Here's the value. Okay, you see here np is not defined, so right now you will see here in my steps we should define now the np. Okay, no problem, just follow me step by step. Now we need another variable. Let's put it here and let's define it as a final decimation, final decimation, and the value, let's put it the value int, and now open with samp rate with 1e6. Now closed this value, final decimation. Okay, now we need to define here the np variable to make it because right now it's error because we not defined, so let's bring another variable and put it here. Now the ID, let's make it as a import. I'm sorry, we need not this variable, just delete it. We need the import block. We need here import block. So let's import it as a import numpy as np. Click OK. As you can see here, the variable here, it's the error is disappearing. So we add this block import. Let's make all this looks like close together, as you can see here. Okay, now we need to bring a osmocom source. Osmocom source, let's put it here. Okay, let's make it bigger here enough. Make sure the output type is complex float 32 and the cycle and the number blah blah blah, default everything is now I see is correct. The channel 0 frequency, make sure to change it to center frequency. ID that we define, so let's make it as a center freak, and channel 0 frequency correction 0, and make sure the channel 0 off, and this is manual. And channel 0 gain, let's make it gain dB, gain dB that we define, and channel 0 if gain 2020, and the channel 0 bandwidth, let's make it as a sample rate, and with this value with 0.8, the channel 0 bandwidth. Let's make samp like this. Okay, the sample rate is sample rate, on channel 0 center frequency like this, and channel 0 RF gain dB like this, and then channel 0 bandwidth, let's make it like this. Sample rate star 0.8. Okay, so channel 0 bandwidth 800 kilohertz. Okay, now we need to bring a Qtgi frequency sync. Qtgi frequency sync. Let's put it here. Okay, Qt, let's make sure it's complex, and let's name it as a like a Spectrum MWK. Spectrum MWK, that's what you like. And the FFT side, let's make it as a FFT length that we defined. FFT, sorry, small letter, FFT length. And let's make it window type is Blackman Harris is nice, good. And center frequency, let's make it a center freak ID, center freak. All this we defined. And the band sample rate, and this blah 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 is good. Let's change the Y minimum to the minus 120 and the Y maximum minus 20. Okay, the Y label relative gain, okay, or gain, no problem, in the Y unit dB. And the update period, it's 0.10, and let's make a GUI hint location, let's make it in 0.031. It's good. In the previous video I show you how to use the grid position in when you launch the software, so you can know how to do these numbers in my previous video. Okay, let's show message ports. No need to show it. Okay, see, everything is nice. Okay, now because we need to connect from Osmocom source output to Qtgi frequency sync input, as you can see here, the input in the left side, so let's change it in the right side. So let's make the flow graph, it's easy to see. So let's right click and rotate counterclockwise, right click, another rotate counterclockwise, as you can see here. Now I see it's now is nice to see. So just click in the output here and to the input here. Okay, now just we need to bring a stream to vector block, so let's bring it stream to vector. Okay, let's put it here. Okay, now make sure the IO type is complex and number of items, let's change it to FFT length that we define. FFT length, and the vector length is 1 is good, and the IO type is complex. Okay, let's click OK here. As you can see that we defined it looks now is 256 that we defined, 256. Now just click here from Osmocom source output to stream to vector input like this. Okay, now we need a block. We need to bring keep one in. So let's bring it, keep one in block. let's put it here. And now here the n, we need to add this formula ID. We need to do it int round with sample rate with Fft length with 1000. So just put this command here in the n. As you can see, int, we open round with sample rate with Fft length with 1000, as you can see here. And the vector length is make it as a Fft length that we defined earlier, Fft length. Okay. Okay, let's can connect from the output here to the input. Okay. Now we need a Fft block, so let's bring Fft here, this. Let's put it here, as you can see. Okay, make sure it's complex, and the Fft size, let's change it to the Fft length. Fft length, and the forward devices, make it forward, and the window is window black Manharis. Let's change the 10024 to the Fft length. Fft length, sorry, as you can see here. And the shift is yes, and the number of thread is 1. Okay, see, everything's nice now. Now let's connect it from the output, from keep 1 in N to the Fft block N, as you can see. Okay, now we need a complex to mag with 2 block. So let's bring it complex to mag with 2. Okay, let's put it here. Okay, the vector length, let's change it to Fft length. Okay, now let's connect it from the Fft block output to the complex to mag 2 in, like this. Okay, now we need to bring integrate block, so let's bring it in integrate. Let's put it here, and make sure the IO type is float, and the decimation, let's make it 100, and the vic length, let's make it Fft length. Okay. Okay, now let's connect the complex to mag 2 out to the integrate in. Okay. Okay, now we need another block. Let's bring it, it's calling log 10. So let's bring this log 10 log 10. Let's put it here. Okay, in log 10 let's make it the n value 10 and the k value is 0 and the vector length, let's make it fft length. Okay, now let's connect from integrate output to the log 10 like this. Now we need to bring a probe signal vector block, so let's bring it, probe signal signal vector. Let's put it here. Let's define it input type, make sure it's a float, and the vector length, let's make it as a fft length. Okay, now we need to connect from log 10 output to the probe signal vector. Let's just flip the input in right side, right click, rotate counterclockwise, another right click and rotate counterclockwise. So let's put it here. Now from the log 10 output to the probe signal vector n. Okay, now we need to bring a block, it's calling vector to stream. So let's bring it, vector to stream. Let's put it here. Okay, make sure the IO type is float and the number items, let's make it as a FFT length. And the vector length, let's make it 1 and click OK. Now let's flip this block. The input we need to the right, so let's just rotate counterclockwise, another rotate counterclockwise, and make it, put it here. Now from the log 10 output to the vector stream input. Okay, now we need another Qtgi, another block, it's calling Qtgi time sync. So let's bring it, Qtgi time sync. Let's put it here. Okay, make sure the type is a float, and let's name it here as a like a average spectrum MWK. Average spectrum MWK. The y-axis label, let's make it power, and the y-axis unit we don't need it. Number of points, let's make it FFT length. Sure, FFT length. Okay, the sample rate and the grid no, and y minimum, let's make it minus 60, and the y maximum, let's make it 40, and the The update period is 0.10, and the disp tags yes, and the GUI hint, let's make it in 0,131. Okay, see, everything's nice now. Let's just flip the input in right side, just right click and rotate clockwise, another rotate counterclockwise. So from vector stream output here to the Qtgi time sync, as you can see, it's simple. Okay, now we need another block. It's calling a frequency oscillating FIR filter. So we need to put here and connect the Osmocom source to that. So let's bring it. Frequency oscillating FIR filter. Let's bring it. Let's put it. Let's put it here. It's nice. Okay, make sure it's complex tabs, CCC, and the decimation, let's make it as an initial decimation that we defined variable value. Initial decimation, and the tabs, let's make it variable low pass filter tabs 0. Okay, variable like this, low pass filter tabs 0, and the center frequency, let's make it a D mode BB freak. Okay, the sample rate, let's make it sample rate. As you can see here, the decimation is initial decimation, and the tabs is variable low pass filter tab 0 block, and the center frequency is D mode BB freak, and the sample rate as a sample rate. Make sure it's CCC, complex tabs. Okay, as you can see here, it's appearing sample rate 1 megahertz, and the frequency is minus 15 kilo, and the tabs variable low pass filter, and decimation is 5. Okay, now let's connect it from the Osmocom source output to the frequency oscillating FIR filter here. You can see. Okay, now we need to bring a decimating FIR filter. So let's bring it. Decimating FIR filter. Let's put it here, and make sure that the type is CCC, and the decimation, let's make it as that we defined, initial decimation ID, and the tabs. Okay, in tabs, let's make it variable low pass filter tabs 0, variable low pass filter tab 0 block. Okay, and the sample delay is 0. Okay, okay, now let's connect from frequency exciting FIR filter output to the decimation FIR input. Okay, now we need another decimation FIR filter. Let's bring it. Let's put it here. Okay, make sure it's complex tabs. And the decimation, let's make it int samp rate with 1 E6 1 megahertz, and let's close it like this. And the tabs, let's make it variable low pass filter tabs 0, and the sample delay is 0, as you can see here. Okay, FIR filter 0 and FIR filter 1. Okay. Okay, now let's connect it from the decimation FIR filter output to the decimating FIR filter number 2 input, as you can see here. Okay. Okay, now we need to bring here a Qtgi frequency sync. So let's bring it, Qtgi frequency sync. Let's put it here. Okay, here make sure the type is complex, and the name, let's name it as a like this decimated channel MWK. I like to name it like this, decimated channel MWK, and the FT size is 1024, and the black man, and bandwidth, let's make it the bandwidth, let's change it as a final rate that we define in the first of the video. So let's change it as a final rate. Okay, the grid, no, let's y minimum, let's make it minus 200, and the y maximum, let's make it minus 60, and the y label, let's label it as a gain, and the dp1, and the update period is 0.10, and the GUI hint, let's make it 3, 0, another 3 with 1. Okay, I see it's everything is correct, everything is nice. Okay, now let's connect from the decimation FIR filter output to the Qtgi frequency sync input. Okay. Okay, now we need to bring a power squash block. So let's bring it, power squash Let's put it here. Make sure the type is complex, and the threshold, let's define it. We make a squash dB, so let's put this ID here, squash. In the first of the video we make it squash dB value variable. Okay, squash dB, and the alpha, let's change it from 1e-4 to 0.1, and the ramp is 0, and the gate, let's make it no, we don't need a gate. Okay, now just connect it from this emitting FIR filter output here to the power squash input. Okay, now we need to bring a quadrature demode block. So let's bring it, quadrature demode block. So let's put it here. Okay, let's define the gain. Let's make it 0.050. Okay, now let's connect it from power squash output to the quadrature demode input. Okay, squash dB, let's make sure we define up the squash dB. Okay, no problem. I will define it. Okay, here in quarter demode, make sure you put the gain as 0.050. Okay, let's make it, put it here. It's good. Okay, now we need a emitting FIR filter block. Okay, before that, just we need to make sure every value is good. Okay, I want to make sure, but why this is squash? Okay, squash. I found the error here. I just missing the type is correct. The squash dB ID. Okay, no problem. Now everything is correct. Okay. Here everything is okay. Okay, now we need to bring another block. It's calling this emitting FIR filter. So let's bring it, this emitting FIR filter. Let's put it here. Okay, now make sure to change the type from CCC to the FFR, to the float real tabs, so the decimation is changed to the initial decim variable that we define in the first of the video. Okay, and the tabs here, let's make it variable low pass filter tabs 0, variable low pass filter tabs 0 block, and the sample delay 0. Make sure it's FFR, the type is a float real tabs, and change the decimation to the initial decimation ID that we defined in the first of the video. Okay, now we need to flip this block to make the input in the right side and the output on the left side. Just right click and rotate counterclockwise, another rotate counterclockwise, you can see here. Okay, now let's put the lines between, connect the quadrature V-mode output to the decimating FYR filter input. Okay, now we need another block. We need to bring a block, it's calling polyphase arbitrary resampler. Okay, we need to bring this block, it's calling polyphase arbitrary resampler. So let's bring it, polyphase arbitrary resampler. Let's put it here and make sure the type is FFR. Let's change it to the float real tabs, and the reassembling rate, let's change it as a 16 E3, 16 kilohertz with a float. Just type like this formula, float final rate. Okay, final rate with 5, and now just close it, and the number of filters 32, and blah blah blah, and the stop band attenuation 100, and the sample delay is 0. Okay, I think everything is nice. Now connect from decimating FIR filter output to the polyphase input. Sorry, we need to just to flip this block to make the input in right side. Just rotate counterclockwise, another counterclockwise. Okay, now from the output to the input. Okay, now we need to bring a power squatch block, so let's bring it, power squatch block. Let's put it here. Okay, make sure the type is a float and the threshold is -200, and change the alpha to the 0.1, and the gate is yes. Just click OK. Just we need to flip this block to make the input in the right side. Just rotate counterclockwise, another counterclockwise. Okay, now from polyphase output to the power squatch input, like this. Okay, now we need to bring a wave file sync. So let's bring it, wave file sync. Let's put it here. Okay, now we just the file location of recording. Let's choose where you want to put this. I just want to put it in like in C user MWK downloads. Let's put it in my downloads. Just click save. The name let's make it like test. Scope. This is the scope. Okay, I put it here in the download location, and the sample rate, let's make it 16,000, and the bit per sample is 8. Okay, the sample rate is 16 kilo. Okay, now let's flip this block, rotate counterclockwise, another rotate counterclockwise. So from power squash output to the wave file sync. Okay, now finally we need a audio sync block. So let's put it here, and let's make it sample rate to the 16 kilohertz, and OK to block yes, and number of input 1. Just flip this block to make the input on the right side, rotate counterclockwise. Okay, now from polyphase output to the audio sync. As you can see right now, I think everything is correct. All the blocks, no error here. As you can see. Okay, now let's save it to the desktop, like Advance SCOPE Recorder Narrow FM GRC. I save it. Now let's generate a Python file, so you can use the Python file in like in Ubuntu to launch it. As you can see, MWK Advance NFM Recorder PY. Okay. Now let's just fire it up. As you can see here, the software is opening. I just increase all these. As you can see here, the average spectrum, the spectrum MWK. As you can see, the scope here is focused here. This is the center of the frequency. The center frequency is 446 megahertz. I will just now let's make it on full screen. I will just bring my radio. Sorry. Okay, I got my radio. Let's make it 446 for testing. Let's testing here. This is Mike Whiskey Kilo. This is Mike Whiskey Kilo testing. Let's increase the volume in my PC. This is Mike Whiskey Kilo. As you can see, I need to correct the value here to put the center frequency here in this flow graph. So let's change it to the 10,000 D-mode BB frequency. As you can see, you're hearing my voice. This is Mike Whiskey Kilo testing another demonstration in GNU-RADIO Companion. Scope, advanced scope recording with the Spectrum 3 scope view. Just right now to try to close this conversation. Okay, now I just want to try here the D-mode BB frequency we make. Let's change the value. As you can see, the center of my radio in the center of the decimated channel in the UK Spectrum scope. Let's change it to value to, like, as you can see here, you hear not clear because I jump up. As you can see, I jump more. Let's go back to the center of that. As you can see, the squatch here, the hardware gain, you can increase it. Okay, now let's going to see in download. Let's go into download folder. So let's see the file. We should make as you can see here. I just bring here the download folder. As you can see here, a test scope here. So let's try to open it using VLC. As you can see, this is the first of the video I make. It's not in the center of the frequency, the scope. As you can see, you're hearing my voice. This is Mike Whiskey Kilo testing another demonstration in GNU-RADIO Companion. Scope, advanced scope recording with the Spectrum 3 scope view. Just right now to try to close this conversation. Okay, now just want to try here the D-mode BB frequency we make, change the value. As you can see, the center of my radio in the center of the decimated channel in the Spectrum scope. Just change it to value. As you can see, everything is well correct. Let's try test number 2. This is my Qtgi testing number 2. Testing number 2. My voice hearing in my PC. Right now we need to check the test scope wave file to see this test number 2 is added to that file. Over. Okay, now let's open test scope here in VLC. This is the first of the conversation. Let's jump.
My voice hearing in my, this is my Qtgi testing number 2.
As you can see, testing number 2 is added.
Right now we need to check the scope wave file to see this number 2 is added to that file. Over.
As you can see, everything is well correct. You can jump to what the frequency you want from here, like you put here like 430 megahertz, 4.3. As you can see here, you can jump to which frequency, 448, like. As you can see, it's jumping into 448. So I will jump here to 448. Let's try it. This is 448 megahertz. As you can see, everything is correct. This is a 3-scope narrow band FM Advance GNU-RADIO companion software. It's nice to build your own like this, and you can create your recorder activity with the scope, focused, zoom, to easy center the frequency by jumping up a little to make the cut of the frequency is in the correct position. Okay, this is Canfor here. Thank you for watching. Stay tuned for another video demonstration in GNU-RADIO companion under Windows 10 for that 73, and bye bye.